Can you determine the turns ratio and impedance of an unknown transformer with just an iPhone and a multimeter? Let's find out. First things first, I'll show you how to identify all the wires for the primary and secondary and center tap. And then to find the turns ratio, we'll inject a small voltage signal in the secondary and measure the output of the primary. That'll give us the turns ratio. And step two, if you square the turns ratio, it'll give you the impedance ratio. And once you know the impedance ratio, you can multiply it by the different impedances of speakers you could use: 4 ohm, 8 ohm, 16 ohm. We're lucky enough that these wires are colored. You can still see the colors on them. It helped to write it down. But if you don't have colors, sometimes you can tell one side have 3 wires out. That's more than likely your primary side, and the 2 wires with the speakers coming out is your secondary. But you could have more wires coming out for different taps on the secondary for different speakers. So let's write the colors down. With our multimeter set to ohms, we'll just start off by measuring from green to red. Now, if your wires aren't colored, it would help to tag them. Just tag 1, 2, 3, 4, 5, however. And from green to red, we get 151 ohms. Now let's measure from green to orange. You see, that's 280 ohms. Then from orange to red, it's 128 ohms. So I would say the red is the center tap, but they're a little unbalanced. Now we check the secondary. Your secondary, I have the least resistance. It's 0.6 ohms. It's almost as short. Now you want to make sure you don't have any leakage from your primary to your secondary. If you did, you might get some high voltage on your speakers or your chassis. Short your secondary wires together. Clamp one lead of your ohm meter to those shorted together, and just go back and test every one. That one's open. That one's open. That one's open. So there's no leakage in between them. Okay, next I'm going to show you how to hook up the signal generator using your iPhone. I'm going to use an iPad because I have to use my iPhone. Just go to the App Store and find you a free frequency sound generator app. This one right here works pretty good for what we need it for. All right, the iPad is just the same as the iPhone, the same apps. Downloaded that frequency generator. I've got it set at 1,000 hertz. And we have, this uses a USB-C to auxiliary cord. Just plug it in. The other end of the cord is a 1/4 inch, and I just have this adapter. You can just use alligator clips and clip onto it. The tip is the plus side and the cylinder here is the negative. But I had this little jack, so I use it. Okay, set your multimeter. Make sure you're measuring RMS voltage and not peak to peak. And we're going to clamp it to a signal generator and just hit play on it and measure the voltage. I have the volume wide open. You see we get 0.662 volts. So our input is be on the secondary is going to be 0.662. Then connect the input to our secondary wire, and it would help to measure the voltage again with it hooked up. So now we get 0.652 volts. So that's the one we're going to use, 0.652. Now measure your voltage from end to end. We know the red was the center tap, so we need the green and the orange. And we get 20.36 volts. Now if we divide the primary voltage, 20.36, by the secondary voltage, 6.52, we get roughly 31.62 volts. Now we need to find the impedance ratio. To find that, we just square 31.62. 31.62 squared gives us about 1,000 volts. Now we just go to step 3. If you multiply 1,000 times 4, you get 4,000. That would be the impedance of the primary if you had a 4 ohm speaker on it. You multiply 1,000 times 8 would be 8,000 ohms. That would be the impedance of the primary at an 8 ohm speaker. And of course, 1,000 ohms would be 16,000 ohm impedance of the primary with a 16 ohm speaker. That's how you do that. It's pretty simple. What do you think, little Sheila dog? She don't care. Now let's check how accurate our measurement was using the iPhone or iPad against the FNIRSI DPO 350P oscilloscope. We got the signal generator connected to the secondary along with channel 1 so we can monitor the voltage going in. And then channel 2 is hooked over here to the primary. We're going to measure the voltage coming out of it. So we'll set our signal generator to a sine wave, 1,000 hertz, and we can set the amplitude of it until we get, then tell it to measure RMS. If you hadn't seen it yet, go back and watch my other video on how to test power transformers using these FNIRSI meters too. Channel 2 is set at 5 volts and channel 100 millivolts. But I want the RMS is right now at 124 millivolts. If we can get it to 1 millivolt, just makes for easier math. 1.2, 0.1, there we go. All right, our input voltage is 100 millivolts going into the secondary. The output is 3 volts. Okay, we have our signal generator. We've got 100 millivolts RMS. You have to make sure it's RMS voltage going in, and coming out we have 3.06 volts. So that would give us a turns ratio of 30.6 to 1. Looking back on what we measured before, our turns ratio was 31.62. And this is 30.6. So it's close. It'll get you in the ballpark. If we take 30.6 squared, that gives us 936.36. Then we come back down here. We had 1,000 before, and we just multiply 936.36 times 4. That gives us, instead of 4,000, 3,745.44. We multiply it by 8, it gives us 7,490.88. And then if we multiply it by 16, it gives us 14,981.76. So there wasn't much difference between using the iPhone and multimeter and the oscilloscope. Now this is an old Radio Shack multimeter I've had for 20 years, and it's been in the garage for a long time. So I don't know how accurate it is. It may not be near as accurate as the oscilloscope at measuring RMS voltage. We could try it with a different meter and see what we come up with, but I think that gets you close enough in the ballpark. Now let's take a known transformer. We're going to use this Edcor and run the same test and see how accurate it is. Okay, now we got our signal generator hooked to the secondary of the Edcor transformer, and I've got my meter hooked to it, measuring the voltage. It gives us 215.8 millivolts in. Now let's see what we're getting out of it. We take the two ends of the primary, measure them. got 5.35 volts. 5.35. Okay, to get the turns ratio, we just divide 5.35 by 215 milliamps. And that gives us about 24.8. We square that to get 614.8. That's your impedance ratio. Now we take the impedance ratio and multiply it by 8 ohms, and that gives us 4,918.62. That's your impedance at the primary. Now if we look at this Edcor transformer, we see that it's a 10 watt, 8 ohm secondary, and a 5K primary. So we wasn't very far off on that. I would say this measurement works out pretty good. Another trick you could use, if you use a 4 ohm speaker into it, that would make your primary impedance 2,500 ohms. You could use that for maybe a single-ended KT66 or a 588-1 tube. If you run it with an 8 ohm speaker, it gives you 5,000 ohm impedance on the primary. That's good for maybe a 6V6 or a 6L6 single-ended. And then if you run a 16 ohm speaker into it, that'll give you a 10,000 ohm primary impedance. Maybe used a 6F6 tube for it. That's why you don't want to run a lower impedance speaker if it's for 8 ohms, because it changes the primary impedance to 2,500. That can make your tubes run hotter. Now let's measure a multi-tap transformer that has 3 secondary taps for different speakers. We have the generator going in 1 tap, and we're checking the output voltage of the primary here. Call this tap 1. Our input is 38 millivolts, and our output is 486 millivolts. Now we'll check tap 2. Just move the signal generator here to tap 2. As the load changes, the input voltage will change too. Now it's 73 millivolts, and the output is 613. Now let's try tap 3. The input is 100 millivolts, and the output is 609. Now we can determine the impedance ratio of those. So if we hooked a 16 ohm speaker to the lowest impedance, the 37.21, that'd give us a primary impedance of 600 ohms. And just going down the line, if we hook that 8 ohm speaker to the 70.6, it would give us 565 ohms. And then we take 164.3 and multiply it by 3.5. That gives us 575 ohm primary impedance. And it's marked on the transformer as a 500 to 600 ohm primary impedance. Well, as you can see, you don't have to have expensive equipment to check these transformers with to get you in the ballpark anyway. In our next episode, I'll show you how to check chokes using the Finirsi 1020E LC meter. I'll be happy to answer any questions you have. Just leave them in the comments and I'll get back to you as soon as I can. Thank you for watching.